longer presentation on this in Campus Grids in June, I think it was. So like this talk is not really about covering everything of Pegasus or anything like that. Instead, I'm going to drill down and see what the workflow looks like running on Open Science Grid, and kind of show a template or an example workflow that is set up to run well in our infrastructure. So just a short overview here. I have 6 or 7 slides. I'll go through them pretty quickly and stop me if there's any questions. So just a quick overview. Pegasus, well, it sits on top of Dagman. So a lot of this stuff will feel familiar when we start looking at details in the workflow. Well, we'll see Condor jobs, we'll see Dagmans, things like that. And really what it is, it's you start with a higher level description of your work. For example, it doesn't have to be a workflow with job dependencies and stuff, but a set of tasks that you need to run. If there are dependencies, fine, you specify those as well. And Pegasus will then take that higher level workflow description and make an executable workflow from that. Think about this as a compiler step. We write code in a higher level language, we compile it down to bytecode. It's very similar to that, except that in this case we were talking about tasks, and we're talking about basic directed acyclic graphs that we're compiling. So one of the examples of what happens during this transformation step, if we start with a workflow here on the left where we have 2 jobs, one hello and one world, and once we give that to Pegasus and plans this workflow, Pegasus will add jobs to this, and add is not the only transform, but it's the most common one. So in the workflow here in the middle, we'll see that Pegasus have added stuff like create directories, staging data in and out, clean up jobs, and stage out and registration jobs. And so this is kind of like the concept. There's the other common transforms that can happen is, for example, clustering. If we have short tasks, Pegasus can cluster them together for you. You can also transform jobs from different styles. For example, if you have a set of serial jobs, you can compile them into like an MPI job. So when you set up a Pegasus workflow, there's basically 4 components that you need to specify with information. And the first one is the abstract workflow that I just talked about. This defines what tasks you want to run, what order, like dependencies between them. But it doesn't have data and locations of software and things like that. We have catalogs for that. So for example, the transformation catalog contains software installed, that's the executables that's needed by the workflow. And there's a replica catalog that has locations of data, especially when you start off the workflow. Well, you need input data to that workflow. That's what's in the replica catalog. The site catalog is what describes your site environment. And in our OSG example that I'm going to show you later, it's much simplified from this. And the reason for that is that the transformation catalog and replica catalog, even though they can be specified separately and they can be, for example, replica catalog can be a file or it can be a service. In the case that I'm going to show you, these catalogs are actually included in the DAX itself, and that's a common simplification of setting up the workflow. There's nothing that stops you from doing them separately, but to make it simple, and for a lot of users, they generate the DAX every time anyways. It's fine to have the transformation replica catalog inside the DAX. In the site catalog, well, defining the environment that we're going to run in is pretty simple because it's a Condor pool. And we don't have any, in this example, we don't have any weird data staging or anything that kind of modifies that site environment. And Therefore, the cycle log is fairly static. We still generate it at submit time, and that the reason for that is that we can share our workflows a little bit easier. We can put the whole thing in Git or something and have other users pull it out, and it will just work in their account as well. I'll show details about this when we start looking at the hands-on part. Another thing I want to talk a little bit about is workflow monitoring. Well, that's one of the value added that you get from using Pegasus above Dagman. There's Pegasus will collect all this provenance about where your jobs ran, how they behaved, data about the environment, things like that. It sticks all that stuff into a database, and Pegasus provides tools for you to query that framework. So there's a Pegasus status that shows the current running workflow status. There's a statistics ones that pulls out stats afterwards, and that's what you see at the bottom here. For example, the 3 lines at the bottom there, it summarizes the resources used by this workflow. So from there we can see that the workflow took 13 hours to run from start to end, but it actually used up 384 days of compute cycles. And there's also a Pegasus plots command that pulls out and presents the same information, but with graphs instead. A common tool that I want to highlight, Pegasus Analyzer. So this is it uses a database, but it also uses some other information about the workflow, and it allows you to debug a workflow. If you run a workflow and it comes back saying it failed, even after retries and stuff, something failed, well, Pegasus Analyzer will show you the job it failed, it show you the error message, and hopefully that will provide enough details that you know how to fix the problem. And this is kind of an alternative to grabbing log files and outputs and things like that. So that's a big advantage. So the workflow I'm going to show you, it's what's on top here. There's six tasks in my workflow. There's no job dependencies in there. It's basically a sweep over a set of input files. And at the bottom, that's what it looks like after Pegasus have added their jobs and dependencies to it. So even though we started with an independent jobs, Pegasus added dependencies there because of data state movements and cleanups and things like that. I'll come back to this picture also once we start talking more about the workflow. And that's it. That's it for my slides. Just mentioning, we have the website at pegasus.isi.edu. There's a tutorial and documentation on there for people that want to, study more on their own after this talk. So let me switch to Putty, and please let me know if the font is too small or something like that, if I'm moving too fast. So I just have to reset something first before we start doing something here, because I did an example. Okay, sites. All right. So, come on. So this is the example. And this is also available for downloads if you want to try it later on. The system I'm running on, it's an OSG submit node. It submits to Glide WMS. It looks like one big control pool. If you wanted to run this workflow, for example, on a HPC system or with a shared file system, well, it would look slightly different. But as a template for Open Science Grid, this is a nice example to start with. So what we have is, first we have a user application. This is this word freak. It's doing statistical analysis of a piece of text. So it will count the words and provide which one is the most common word and so on. And also, we also have a set of user inputs. They are in here in the inputs directory. If we look there, we will see that there are 6 books. These are from Gutenberg project. This is open public domain books. And so the idea here is that the user comes in, it has a set of inputs, application, and needs to run one for each of those inputs. In this case, obviously, it's statistical analysis of this text, but it translates well to, for example, it could be protein folding or any kind of sweep that you have over a set of inputs. So that's the idea. So what we need to do is we need to generate a DAX generator for this. We need to be able to describe the workflow. And a DAX generator, well, it creates this abstract workflow. And if you look at this, this one is in Python. There are APIs available in Java and Perl as well. And you can also write the abstract DAX by hand, or it's XML, so you can write from any tool, which is common if you already have a pipeline generator, for example. You can make it spit out Pegasus DAX XML, and you don't have to generate the DAX by our API. So a couple of things here. By the way, do people see when I highlight? Can people see this? Oh, yeah, perfect. Okay. Okay, so of course we include this Pegasus DAX API, and we start with creating the DAX, abstract workflow. One of the things that Pegasus also can do for you is notifications, and this is also Conda can do this, but at a more coarse granularity. In Pegasus, we can do it pretty much for any event in a workflow. A common one, and the one that I'm using in this example, is to send email whenever the workflow is changing states. So that means I will get an email when the workflow starts. I will get an email when if the workflow fails or when it ends. And it's kind of nice because if you're running a bigger workflow, you kind of want to just fire it off and kind of forget about it until something is important. You can also do it, like, for example, get notifications on job failures and things like that. But in general, putting it on for the whole workflow is pretty nice. So the next lines here, next 4 lines. This is where we specify our executables. And so I mentioned before that there's a replica catalog. Well, this is the shortcut replica catalog that you can have in the DAX. If I didn't have these 4 lines in here specifying where my executable is and things like that, what would happen is that Pegasus would try to plan a workflow, and it would say, well, I don't know anything about where the word free executable is, so I can't continue planning. Either specify it in a replica catalog or in the DAX. In this case, well, we put it in the DAX. And you can specify multiple ones. Like in this case, install equal to false. That means that we will ship it with each job. If you have a more complex application, and for example it's on CVFMS, then you can just say that it's installed, and you put the location instead of a location on the submit directory. We'll just use the CVFMS path to it. You can add profiles. In this case, I'm adding a Pegasus profile, and I will show that later. But you can also add things like Condor profiles, requirements, like if you want to have specific requirements for this job, if you want to match against certain sites or anything like that, you can put that in here as well. All right, the next section of this is this loop. And all we're doing is we're looping over this input directory. We're saying for each and every of those input files, we'll want to create one job. We have to specify where the data is, okay? And that is the replicate cal log shortcut. So in this case, we're saying, well, for each of those inputs, we know where it is because we just did an ls of that directory. Build the path for that file name and tell Pegasus where that input file is. If you could do more complex stuff here, you see we're using file a lot. You could put any protocol basically that's common on OSG. You can put gridFTP or HTTP or SRM and URL instead for the file, and Pegasus will add stage jobs to get that data to the correct location at runtime. And then the last part, well, this is where we actually define the job. We give it a name. This has to match what we did up here for the executable. With telling Pegasus what files to expect. There's actually two files. There's an in file and an out file. The in file is the input file from the user. The output file is the statistical analysis output. We have to specify the files. The Pegasus. We have to specify the files for all our tasks. And the reason for that is that Pegasus actually tracks this. And if there is a file that exists in one site and it needs to move to another one, well, then Pegasus can detect and move files accordingly. So all files needs to be tracked or added as input and output files here. And we also add job arguments. This is standard shell arguments, right? Okay, and then the last thing we do, well, we write it out into XML. And I will show the XML here in a second. Any questions about the DAX generator? No? Okay.
There is a question from the chat. Miha is asking if it's possible to create output for each book in the file and then consolidate.
Yes, I have an example of that later on. I have another example I can show later. Yes, but then you have to add basically a task that do the consolidation, right? And that's a common one. I have a DAX I can show where that happens. Okay? A good point here though, like these files, inputs and output files, they have to be unique, right? So if you have a task that always writes out, my output.txt or something like that, right? That will not work. They have to be unique file names. So either you have to wrap that executable or you have to give it the command line argument to write to a unique file. And that's part of this tracking all the inputs and outputs. If you reuse file names, for example, in a workflow, not allowed. Okay, so that was the DAX generator. The next file, Pegasus RC, is just a settings file. I'm not going to cover it in this talk. It has a couple of properties that Pegasus needs. And the submit file, well, this is a convenience script, and it's something that we started doing a lot with users in OSG. Most of our users, they put some new stuff in the inputs directory and just run submit. They don't really want to go through multiple steps of planning and submitting and all that stuff. So it's just a convenience script, and it has 3 parts to it. Let's start from the beginning here. The first thing we do, we run that DAX generator that we just made earlier. And the second thing we do is that we create the site catalog. And creating a site catalog, you don't really have to do this every time. But in the case here, this is the reason we're doing it in this case is that, for example, paths on our submit host, like here's one, changes depending on what user is running the workflow. And so having creating the sites catalog every time just updates those paths to different work directories and things like that. For larger collaborations, well, what they do is that they have the site admin maintain the sites file, and they don't really have to, you know, change it every time. It's just reused for all the users. But because this is an example, we want it to be easily downloadable and executable, and you know, we don't want to hard code things in here. So there's two entries in here. There's this local entry that you always have to have. That's the submit node, and then you have to specify at least one compute site. And in OSG's case, right, we're running with a Glide AWS overlay over OSG, so we don't really need to list specific sites or anything here. We are just telling Pegasus there's a Condor pool, and we are going to use Condor.io, so we don't need to know any directory structures or anything like that. We'll just run in whatever directory that Condor tells us to run. Similarly to that, talked about the job, we can add profiles here to different namespaces. In this case, we're telling Pegasus it's a Condor job. We're running Vanilla Universe, and with the product name of OSG staff, this is the specifying product name is a specific a key that we need on this submit host. You don't need it on your own Condor pool. But it's still a pretty simple site configuration, right? There's really no details about OSG sites in here. If you wanted to run Pegasus, for example, against an Exceed site or a local campus cluster, and you want to use Globus instead of Condor, you know, this will be a little bit more complex. You would have to put in endpoints for where Globus Gram is installed, where data staging servers are, things like that. So you know, it's simple in this case. Could be more complex in other cases. And the last part of this file is to plan and submit this workflow. So Pegasus plan, well, that's what does the planning. There's a convenience flag submit that plan and submit this, and we kind of just giving it all the pieces that we created so far. There's a configuration file that said we wanted to ignore. Here's sites, which goes back to that site handle up here, Condor pool matches. Directory, where do I want Condor, where do I want Pegasus to put this workflow while it, you know, to execute it. Again, this is kind of submit host specific. We have a local scratch file system where I want Pegasus to do the work. Where to put the output files. You can specify other sites in your site catalog and use those as output sites. For example, if you want to store your final outputs in SRM, or if you want to do, you know, put them on your local campus or wherever you want to put them, you can just specify a site and tell Pegasus to transfer the outputs to that site at the end. And there's the DAX, and as I said, it's convenience submit command. So are there any questions on this submit convenience script?
So there is a question from Derek in the chat. It's saying, it's asking if this example doesn't have any dependencies.
Okay. Well, so that's actually a DAX generator, right? So what we would do here, right? In this case, now we added a job. If there was dependencies, we would have to add a line saying, you know, job A depends on job B, and you think about it as working with a graph, right? You have added the nodes. Now you just have to specify where the edges are. Right? And one thing that's important to understand here, though, is that you have to add those edges manually, even though we have all the data, like supposedly all the data pieces here, and we're tracking those. Pegasus will still not add edges automatically. For example, if you have a job that outputs a piece of data, and you have another job that needs that as an input, the fact that we already specified the same file as output in one case and input in another case does not mean that Pegasus will add an edge in that case. You still have to tell Pegasus specifically, okay, there's an edge between those two. Okay. And I can go back and I show you a bigger example with dependencies and things like that in a second here. But let's step through this first with all the directories and stuff, because it's much easier to understand it when it's you know, when it only has 6 jobs, right? If I show you a bigger one, it will just be confusing. So to run this workflow, well, we will just have to run this submit command, right? And it looks a little bit weirdly formatted because I'm using a big font here, but the point is that Pegasus says that the workflow has been planned, and it tells us this directory here, saying here's the new work directory for this workflow. And this path is important because it's used as a handle to this workflow. And so we're not using, for example, a job ID to track the workflow. The reason for that is, well, this handle is you know, more stable than a job ID. For example, this directory exists before and after the workflow actually has finished or started or finished. Or if you rerun it, well, you still have the same handle. You still have you know, even if the job ID changes, you still have the same handle. And so all these tools I talked about before, Pegasus status, Pegasus remove, Pegasus statistics and analyzer, they all take this workflow directory as a handle to the workflow. So for example, to check the status of this workflow, well, here's Pegasus status -L, and it will just, you know, show us what the jobs of this workflow is doing. So currently there's nothing, right? It tells us that the workflow is running, and down here it tells us what state these jobs are in. This is similar to the output you will see in Conrad Agman, right? How many tasks are unready, ready, in pre-state, and in queue. So lots of information here. If we keep on running it, we'll see, you know, jobs being added. There are 6 WordFreak jobs, you know, in the queue, but in the idle state. So if we look in this directory, let's see it in here. So there's a lot of files, obviously, but some I want to point out. The ones that start here with WordFreak, well, that's the workflow name, the name that we gave it. We'll find there's a DAG, right? If you look at this DAG again, look at this DAG. Here's all the jobs. It has dependencies in here. So just going back for a second, what has happened is, if you look at that PowerPoint slide again, where did that go? There we go. This one, right? So what happened is that we specify these 6 jobs up here. Those are the ones in the abstract workflow. Pegasus planned it. The purple ones are still there, but there's new jobs, staging jobs. There are create directories up here. Oops, sorry. Create directory. There's stage out and cleanup jobs scattered around here. So that's what we're seeing in this directory. If we go back again, these are the relationships here, parent-child relationships between staging jobs and our compute jobs, for example, here. You know, this compute job depends on this staging job running before it. There's also other things. People that have been working with DAGs before will recognize dag.dagman.out. That's a standard Dagman log file where it shows you know, state of all the jobs. Okay, actually our job, it's already over. So if we run Pegasus status again, if I don't specify directory, by the way, it assumes the current working directory. So I run it in here saying, okay, 100% done, great. But if we keep on looking in this directory a little bit, so we'll see there's staging jobs, there's submit files. If we take a look at one of these, one of the compute jobs, right? These WordFreak 00005, you will see that there is a submit file. That's a conjure submit file, just like what you would expect. It's maybe more verbose than most, has a lot of stuff in it. And there is a shell wrapper, and this is depending on how you plan this workflow. If you planned it against, for example, an HPC machine, you may or may not get this shell wrapper. This is it depends on data staging and things like that. In this case, Pegasus determined that we needed to wrap the executable, so that's why that was added. If we look at the output, okay, so this is standard out of this job, and I told you earlier that Pegasus is collecting all this provenance information. Well, it's doing that by wrapping the executable in something called Kickstart. And Kickstart tracks the process, collects information about it, and wraps it all up and outputs all that stuff for each executable. So for example, we will see things like exit codes. We will see things like, well, what argument did this job actually run with? We will see a usage, for example, how many U time and S time and all this stuff. Permissions. There is environment in here, or somewhere further down. There's the environment it ran under. So there's a lot of information in this. The jobs standard out and standard error is in here somewhere as well. So there's a lot of details. And that happens for all the jobs. When the job comes back, one of the things that happens is that the standard out and standard error gets rotated. So you see the .000 at the end of these files. If there was a job failure, the next time if it ran this job, it would just get the next one would be 001, 002, and so on. So you will have a complete record of all the standard outs that happened, the standard errors that happened during the job failures. So that's pretty neat. And then all this information, or what happens is that Kickstart record gets parsed, and interesting information gets put back into a database. So, and that database can then be queried with things like Pegasus statistics. So if we run Pegasus statistics, it will tell us again, what happened to our task. We didn't have for example, we can tell that there was no retries, there was no failures. All of them were successful. It took 3 minutes to run our workflow, which is actually longer than it would take to just run the task one by one. But that's because this is an example. In a real case, the wall time is pretty much always smaller than the cumulative time. If we run Pegasus statistics, and we will want to create a little bit more data here, we can look at, for example, breakdown. It will give us very much details on how the different tasks did. So WordFreak was our executable. We can get max, mean, and total minimum of all those jobs. So that's and you can also get, if you look in statistics now, statistics, you can get a lot of breakdowns, different jobs. There's more data than you ever want to know about the workflow right here. I said Pegasus Analyzer, well, it will show you failed jobs. In this case, there was none, right? We're all happy. Let me show you what would happen if a workflow failed. I prepared another workflow here before that, and it had errors. Yes, Analyzer. So in this case, it will tell me this is the task summary, where it ran, what the executable was, input, stuff like that, exit codes. It will tell me what the error was, what happened, standard out and standard error. So in this case, you know, it was something I introduced into the job, and you know, so there's not that really interesting failure. If we look in this directory, though, we'll see that these files get rotated, right? Standard out. So there's 4 tries by default. You see the error files are the same ones. And let me see, did I forget something? Share directory. Okay, so any questions on this work directories?
No question, no.
No question, okay. Well, so it can be a little bit overwhelming, obviously, but you know, part of Pegasus is that to abstract this out, you don't really have to go in here and dig if you don't want to. But if you do, you know, you definitely have this just like with Dagman, you can go in here and kind of look at stuff individually. So somebody asked earlier about like a bigger workflow or with dependencies. Actually, that does not have dependencies. Let me see. Yes, maybe it does. Let me see. Blast. Yes, it does. Okay. So, okay, let me think about this. How should I explain? So this workflow is running blast, and then at the end we want to summarize the outputs, right? So the basic idea is that, and actually in this case we would just want to concat them all, but the idea is the same. If you want to filter, concatenation is the same idea. So what you will end up having is a set of blast jobs. One level below that, you will have jobs summarizing that output. And you know, if for a small workflow, what you can do is you can say, well, I want one summary job for the whole workflow. But if you want to run a bigger workflow, if you have a lot of jobs, you can't really do that. Then it's the same problem as you have as you want to on the command line, for example. You want to do ls-star, right? If you have a lot of files in the directory, that's just not going to work. The error is usually something like command line too long or something like that. So in this workflow, what we're doing is that we're saying, okay, we'll take 20 blast jobs. We want to summarize for those. We'll take the next 20, the next 20, or whatever the number is. And once we have all those summaries, we'll move down one level in the workflow and summarize the summaries, and then move down until we're done. So it's a way of scaling this filtering really well. And so was it the DAX that we want to look at? Remind me about the question again. Or the DAX generator.
The question was simply if about the job before, why it had no if it had dependency or not.
If it had dependencies, because like we started without dependencies, and then we added why Pegasus added dependencies? Is that the question?
The question exactly was about the previous example. I was just asking if it had dependencies or not.
Oh, I'm sorry. Okay, well, I led you down a long path for nothing. Yes, in that example, we started off with no dependencies. It's easier to see in this PowerPoint again. Right. So we started off without any dependencies, but Pegasus, when it added in the jobs, it had to do dependencies because of ordering and dependencies, data dependencies. Does that explain it? Okay, fine. All right, so I just want to show you on this bigger workflow. So obviously I ran this before because it takes too long to run it inside here. But if you run Pegasus statistics on this one, it will be a little bit more interesting. Again, we started with 1,000 jobs. Pegasus added a bunch, 1,053. There was no retries. The workflow took 8 hours to run, but the cumulative wall time was 17 days. If we look at, let's go and do a detailed one. If we look at the breakdown again, so we'll see things like the min, max, and mean of this task. And this is kind of useful, right? Because a lot of people that come to us, they have no feel for how long is the job's going to run. If it's too long or too short, we might have to do something special for them. So like being able to just look at this and saying, yeah, okay, I know that my job takes 1,500 seconds on average. It's a very useful tool. I think that's all the stuff I want to show you. One more actually. So going back to our first example, the word freak example, right? So we're back here. I just want to change one thing. In submit, when I plan, let me just add cluster horizontal. Okay, I'm going to submit this. All right, so So what I just did is I turned on task clustering for Pegasus. And what I told it to do is I said, these jobs are short enough that 3 of them can be run one after another one, and that will make a longer job that easier to handle, for example. So that's what happened here. We started off with 6 jobs. Pegasus planned it down to only 2, right? And if we look inside here, what really happened is if you look at the executables, well, there's 3 of them. There's the first execution, there's the second execution, and here's the third execution. And Pegasus will take care of this, the outputs and all that stuff, so it will all come back correctly. But it's just like something that's a very good feature when it comes to running workflows with short jobs. There's an overhead of scheduling these jobs. If we can cluster them together, make longer running jobs, it will just run and scale better on a system like the Open Science Grid. So, any questions?
Yeah, I have a question about the statistics. Those are all collected through the Pegasus infrastructure, or you parse the logs of the different queue manager or so?
Well, so it's...
So do you have like
what?
the wrapper or more the...
Yeah, so the main one, let me back up here again, I'll show you. Let's do this one. All right, so we're back to the original run we did, right? So part of the data comes from the kickstart. So if you look at this output, right? Here's the usage, here's the times, like the runtime of the task. So that's part of what goes into the statistics, and we summarize that up. If you don't run with Kickstart, which is an option, we will use the Condor reported times, right? Because Condor has all that stuff also. If you look in the job log, for example, right? Here's the run times of the. Let me go down and find something interesting. Well, they're all 0 because it's so short. But yeah, but by default, Kickstart is used for most of the data. If you're not using Kickstart, we're falling back and grabbing the Condor reported times. Anything else?
We actually started the microphone from all the attendees. Is there any more question? Sorry, there was one from me. How the user of WordFrag uses this program, if they use from the command line or with a portal. I think it's an example, or it's something that you had actual users.
Well, so, yeah, this example, WordFreak is just an example. I mean, the idea is that people kind of download it and base the new workflow on it. So this one is a command line one. The blast one I showed you is going to go behind a portal. It's pretty common actually. You know, like Pegasus. The Pegasus system is mostly command line driven. We're working a little bit on doing a little bit of services and stuff, but in general, command line is where we work. But it's pretty common that you run it behind, for example, NanoHub and different Galaxy or whatever the portals are, where the user uploads maybe a set of queries, and on the back Pegasus splits it, runs it, summarizes it, and gives the results back to the user. But we also have a lot of people that run by command line. I mean, that's majority of our users. They come in and just hit submit and wait for results and copies it back to their machine. It's a very common human workflow.
So do we have any more questions for Matt? Feel free to either type or to speak with the microphone. I think I don't see any more questions.
Well, it's easy, you guys. We're pretty easy to find again. Pegasus ISI.edu, and there's mailing list and emails and easy ways to contact us. So if you have anything else, let us know later.
Thank you, Matt, for the presentation. So I also like to mention that next week there is the OSG CIC workshop at Duke, and Matt will be there as well. So I don't know if some of you are attending, you can ask further question in person to him next week. And we will also broadcast via Adobe Connect the session at the workshop. Let me type the URL in the chat, just a second. But you will receive notification about it. This will be the URL for next week, Tuesday and Wednesday sessions at the workshop.